Hello and welcome to another episode of the Geotechnical Engineering Podcast. In today's episode, we're talking about Dr. John Thornley, PE, Vice President and Senior Geotechnical Engineer at WSP in Anchorage, Alaska. We'll be talking about the unique challenges that engineers face in cold regions, as well as the impact of climate change on infrastructure in permafrost regions. I'm your host, Jared Green, and I'm excited to be bringing you another episode of the Geotechnical Engineering Podcast. And with that, let's dive right into today's episode. All right. Well, John, thank you so much for coming on the show. How are you feeling?
I'm feeling great. It's a nice Monday morning here. Sun's out, it's a good day to be in Alaska.
Excellent. Well, thank you so much for carving us some time to talk with us. It would be helpful if you could start by telling our listeners a little bit more about yourself, maybe talking about your career journey into geotechnical engineering, and then, of course, talking about what inspired you to focus on earthquake and cold regions, that type of engineering.
Okay, sure. So my path to engineering has been a little bit different than a lot of people's. I started off as a teacher in the Peace Corps. While I was in the Peace Corps, I was in Southern Africa in a little country called Lesotho, and started getting interested in groundwater hydrology. Groundwater is a pretty important issue in Southern Africa. And so I thought about going back to school and getting my master's degree in hydrology. And somebody said, hey, if you went into civil engineering, you could do hydrology and have a job. So that's anyway. And I thought that was a pretty good piece of advice. And so I went into civil engineering and got a second bachelor's in civil engineering at University of Reno. And while I was there, I took some classes in earthquake engineering from Raj Siddharthan and John Anderson, and really fell in love with earthquake engineering and stayed on in Nevada to do a master's degree. And before the Peace Corps, I had been in Alaska, and Alaska was calling. And so after my master's degree, I moved back up to Alaska and started working up here. And Anchorage is a great place because it's seismically active. And so it's an interesting place to study earthquakes. And there's a lot of kind of components to projects that require some earthquake work. And I still had some unfinished business with my studies, and so I went on and did a PhD with University of Strathclyde in Glasgow. I was actually a remote student before remote learning was cool, and studied under John Douglas at the university there in Strathclyde, and completed my PhD while working here in Alaska. So it was an interesting kind of pathway, but I've had a lot of really fun times here. And I'm currently a geotechnical engineer at WSP USA here in Alaska. So I've been with Golder, now WSP, for roughly 12 years.
Excellent. No, that's great. I appreciate you kind of walking us through that. It sounds like, you were going with life, and as you were going with life, you said, wow, that looks interesting. Let's study that a little more.
Yeah. And the cold regions side, I guess I didn't touch on that, but cold regions, Alaska, we have frost depths of greater than 10 feet in some areas just in Anchorage. And so working through those aspects is an important part of every project. And so we've got permafrost up north, deep seasonal frost down here in the southern part of the state. And so it is part and parcel with nearly every project as well.
Got it. So you're telling me that northeastern U.S., where I say there's a frost depth of 3 to 4 feet, I haven't seen anything, right?
Right. Yeah. Our water and sewer system are buried about 10 feet down just to protect from frost. So that's interesting. Yeah.
That's great. That's one of the things I love about this podcast. Talk to people all over the world. It's like, what's normal for you is not normal for me, and vice versa.
Yeah. Yep.
That's great. Well, Dr. Thornley, it would be great if you could walk us through, and you gave a hint of this, but walk us through some of the unique challenges that engineers face when dealing in cold regions, especially where you are in Alaska.
Yeah, so I would say that some of the unique aspects are like you say, the frost penetration, even when permafrost isn't an issue. Just the working through some of these cold regions aspects. I teach a class or part of a class at the university for called Northern Design. It's at University of Alaska Anchorage, and it's a class that architects take for licensure in Alaska. So Alaska requires an extra class above and beyond your testing for cold regions to give you a hint for some things. And it's pretty interesting to have those conversations with folks from generally outside, kind of wrestling with some of these cold regions issues. And then, the other piece that is rather challenging is climate change, and how things are changing quite rapidly up here in the Arctic and subarctic, and we're starting to see, some real impacts from climate change on existing infrastructure, as well as how are we going to address that with future infrastructure. And so that's actually been a really interesting conversation to have, because there's no real guidance on what we should be looking at for the next 50, 75 years. There's a number of climate models, and as you look at the impacts of those climate models, depending on which, trajectory you choose, that ends up in, dollar signs for your client, right now. Right. And so it's an interesting kind of a balancing act as you're looking at, long-term solutions, in a changing environment. And it's pretty interesting time to be an engineer. And there's some really fascinating challenges, not only with new infrastructure, but again, with existing infrastructure, and how you can limp it along and get more design life out of those structures. So,
yeah, it's definitely a lot to think about. And, you think about the cost to doing something versus cost to not doing anything,
right?
What your risk tolerance is. And then you also have to sell it, right? Like, is this something that is something that you need to focus in on, or can we really wait? I think that those are some of the things that come to mind when I think of climate change, but it truly is significantly impacting infrastructure, especially in permafrost regions, I have to imagine. So what are some of the most critical effects that you've observed, and how can engineers better prepare for these challenges as climate change is here?
Yeah, I think that, there are a lot of things that are changing, and performance of structures is kind of one of those things. And I think that the big picture, the best thing that engineers can do is kind of step back and look at the overall site, the overall picture, and ask a lot of questions, right? How did we get here? What is the geomorphology at the site, especially on the geotechnical engineering side? How are things going to behave going into the future? I would say that there aren't a lot of, bad designs, but where we see a lot of failures these days are designs that things have changed since the design was done. And the engineer may not have contemplated those kinds of things happening. For example, impacts of water moving through a site. Water is why we all have jobs as geotechnical engineers, right?
For sure.
And even more so in permafrost regions, where you can have really significant impacts, from on permafrost due to thawing and other things, especially with as it relates to water. And so looking at that kind of big picture and understanding how you can manage surface water, especially, is probably a big a big aspect of northern design, especially. So.
Excellent. Now, you've been a part of projects that require you to assess liquefaction hazards as the permafrost thaws. So can you describe what this entails, and also a potential risk to infrastructure?
Yeah, so this is kind of an exciting area. So we're used to, geotechnical engineers are used to the tools that we have, SPT, blow counts, CPT, all these site characterization tools that we use. And in permafrost, we'll take samples with an SPT. Oftentimes we use a larger sampler to drive into the frozen ground. But we typically will count the blows and all that, but we typically throw the blow counts out the window because blow counts in frozen ground don't tell us a lot other than things are really hard, right? And so stiff ground is, frozen ground is stiff ground. And as long as you can keep it frozen, it doesn't have a liquefaction hazard either. The challenge is these sites that are frozen now, but thaw over time, and now become liquefaction hazards because they're thawed now, right? And so you have a site, say near a river where you have sands and gravels, but when you go and do your SPT blow counts, you find that the blows are really high, but you're really driving a sampler into frozen ground. So how do you characterize the potential for liquefaction? And it's a really challenging issue, and I think one that we're just beginning to start to look at. And what we see is I was working on a project specifically that there was an airport that was built in the 1940s, and depth of thaw of the permafrost was over 100 feet deep. And if you go just off the runway into the trees, the permafrost is less than 5 feet deep, right? And so the SPT blow counts that we were using, when you use the simplified screening procedures, come up as liquefiable in the runway area. But the building that was going to be built off in the trees, the blow counts were really high, right? But it was the same sands and gravels that we had underneath the runway. And so in that case, we essentially used the analog, if you will, of the runway blow counts to estimate the liquefaction hazard. And so without proper tools for characterization at time of your study, you have to step back and kind of think about what kinds of materials are you in? Is it just a frozen silt? Maybe it's not. Maybe it's not going to be liquefiable. But frozen sands and gravels with any kind of ice in them, those will likely be a liquefaction hazard in the future. And so I think that it's an interesting piece. Where we're starting to really study that aspect of the changing of the permafrost and the changing of the landscape, especially as it may impact infrastructure in the future. And these are questions that we haven't always asked in the past, and they're now becoming a much bigger issue. So
wow. And is this something? And again, I'm just not familiar with northern design. Is this something that it really is being triggered because of climate change? And prior to that, permafrost was permafrost because it was permanently frozen, right? So this is really something that you'd have to look at this everywhere, every project, right?
Yes, yeah, wow. Absolutely. And one of the things that's happening also in conjunction with that is we're getting a better understanding, a better characterization of the seismicity in Alaska, and we're realizing that our past design codes, weren't, up to what we anticipate, the earthquakes of the future looking like. And so the hazards going up, the permafrost table is going down, and that certainly changes the way that we're going to be designing in the future.
Got it. Wow. So let's switch gears a little bit. We're still talking about climate change, but relocating communities. If you have to relocate a community because of climate change, that's significant, but it's also a sensitive task. Can you discuss the most important learning outcome for projects you've been involved in Alaska where you had to relocate communities?
Sure. Relocation is a really sensitive topic, right? Especially some of these communities have been in their current location for greater than 1,000 years even. Kivalina, I think the last time I heard it was 1,500 years they'd been on this spit. living next to the ocean that provides for them. And now they're looking at relocating up the hill to higher ground because of storm surges and other climate related issues that are impacting them. And so it's getting that consensus to move the community is a challenging deal. Not my challenge, but when it is time to make that move, choosing the right location and coming up with cost effective solutions, because moving a community is very expensive, right? Building all the infrastructure. We look at cities, and these cities, we've been building infrastructure, for years and years, but all of a sudden you're going to plop people, into a spot that has not been developed in the past, and so it's quite expensive. And I think the biggest, lesson to learn is do it right the first time. And I've seen, because of the expense, there's always the desire to try to cut some corners and reduce fill thicknesses or what have you. We know better, but sometimes we are more excited about cutting some costs initially that are going to pay in the end. And so steadfast, thoughtful engineering, looking for efficient solutions, but they may not always be the cheapest solutions. Those are the tasks that we really have ahead of us. And I think that the biggest thing is just do good engineering, and make sure that those recommendations are ones that you'll see the infrastructure last for years to come.
That's definitely signs of good engineering is when you're thinking about not just today, but beyond. So let's see. So in your role as chair of the Municipality of Anchorage Geotechnical Advisory Commission, it's a mouthful.
Yeah.
What initiatives are you currently pushing forward to mitigate geotechnical risk?
Sure. So it's a really interesting commission. It's one of only a handful, maybe, across the United States. And the Geotechnical Advisory Commission started as a result of the 1964 Great Alaska Earthquake that impacted Alaska pretty substantially. And it came around in the 70s. And the goal of the commission is to advise the municipality related to geotechnical hazards. And one that pops up all the time is, I want to build on this piece of land. There's nothing here. Why can't I build there? And we've identified certain areas within the municipality as kind of these no build or high risk areas to build on. And so one of the things that I see, my role, especially, I've been on the commission since 2009, and one of my roles of that is kind of historian, if you will, and reminding people why we've made some decisions to not build in certain areas, and also looking at other seismic hazards within the municipality, liquefaction and some others to make sure that we're building in areas in a responsible fashion. And so we provide a lot of guidance to the municipality related to that. Another initiative that is I think an interesting one, and it's a long-term kind of slog, is building code enforcement. Yeah. And it may surprise you, but not all of Anchorage has building code enforcement. So we have the building code across the municipality, but it's not always it's not enforced in certain parts of the city, and so you can build whatever you want. And what we found in the 2018 magnitude 7 earthquake that we had here, a magnitude 7.1, was that the buildings performed a lot better in the municipality that had enforcement than areas outside of the enforced building code. And so we found that building codes work, but they only work if you enforce them. so trying to expand the enforcement of the building code is something that the GAC continues to kind of slog along with as well.
Got it. And that enforcement, is it tied back to not having enough personnel, or it just hasn't happened yet?
Well, so
Customers.
it's a little bit different. In the 70s, the municipality of Anchorage grew to encompass outlying communities, and those outlying communities fell outside of what we call this building safety service area. And so the building safety service area is the old core city of Anchorage. And then these kind of bedroom communities, if you will, outside of that service area became exempt from the enforcement. And you know, as good Alaskans are, we don't like people telling us what to do. And so those communities have not been very excited about having additional regulation. And so it's a hot topic, I'd say. And it has really nothing to do with personnel. It has everything to do with the free spirits of Alaskans. So,
Got it. Thank you for clarifying. Got it.
Yeah.
Okay. So with your involvement in international associations, how do you see the collaboration between countries benefiting the field of geotechnical engineering, especially in studying permafrost and then also seismic activities?
Yeah, so on the permafrost side, you know, one of the big things is you know, permafrost is an international issue, right? You know, we have you know, Canada has a large area that's underlain by permafrost. You know, Russia as well, and there are, you know, multiple countries that have even high altitude permafrost. You know, due to you know, their say the Alps in Europe. And others, and so it's a large community, and Alaska, you know, and the work that's done in Alaska is only a small part of you know, the studies and the research that are ongoing as we look at you know, research related to permafrost, climate impacts, engineering, and so on. And so it's if we were to isolate ourselves and only talk to you know, fellow Alaskans, you know, we'd really be missing the boat, because there's a lot of great research going on out there abroad, and so you know, communities like the International Permafrost Association, you know, really foster that science and engineering collaboration and communication. And then, you know, at a more local level, the U.S. Permafrost Association, which I was past president, you know, helps to, you know, again, make sure that we're communicating with the international folks, but also, you know, more local collaboration between engineers and scientists. And so the big learning topics that, you know, kind of come out of that are different ways of doing things and solving problems, and it is, you know, an international issue and topic. And so if we weren't looking internationally, we'd be missing the boat. And I'd say that's very similar as well to you know, earthquake engineering. And you know, while there's a lot of great research that's happening in California, you know, not all earthquakes are California earthquakes. And so, you know, seeing the wider spectrum of thoughts on how we can build to you know, better resist you know, the damages related to earthquakes, I think it helps not just the engineering community, but the world at large.
That's excellent. I know it's going to be helpful for folks listening and watching, because it's really collaborative. What we do as engineers, especially civil engineers and especially geotechnical engineers, is collaborative. So what you're saying, I completely
It's true.
agree with there. So let's see, we'll change gears a little bit. Let's talk about balance, you know,
Okay.
well-being, work-life balance, life-work balance, work-life integration. People have different ways of calling it, but how do you balance your professional commitments with your personal interests? I believe you like to cycle and travel. And do these hobbies offer any insights or benefits to what you do professionally?
Yeah, I mean, I would say probably the first thing is I might not be that balanced. Some who know me might not agree with my my balance, but the reality is I really like engineering. I really like geotechnical engineering, especially, and it's what gets me out of bed in the morning, right? And so you know, solving problems, working with people to you know, do great projects. Those are really exciting things, and so, you know, spending my nights and weekends thinking about engineering is not a chore, so you know, so there's a little bit of a kind of misbalance. You know, I really have embraced you know, engineering as a profession, right? But, say cycling gives me a lot of opportunities. Cycling is a very lonely sport. In reality, you spend a lot of time just kind of riding a bike by yourself, which gives me a lot of time to contemplate and think about, things. And when I'm wrestling with a tough issue, sometimes nothing's better than a good long bike ride to kind of sort things out. But travel is actually, one of these things, speaking of international, collaboration, I've been able to incorporate, my love of travel, with some of these things by going to conferences abroad. I've spent some time in Chamonix and in Puigcerdá, Spain, and Potsdam, Germany. And so I've been fortunate, with my company to, they provide support for, attending these, conferences, but then I'll take a little bit of time after or before to, really enjoy the place. And I nothing's better than a great conference in France, because it gives me I really enjoy France, and it gives me some opportunities to spend some time there with my wife and children.
Excellent. Well, before we take our break, what's the final piece of advice you can give to our engineers, especially those that are starting in the field of geotechnical engineering, and they might even be looking at seismicity, or they might even be looking at permafrost? You never know.
Sure.
Or watch from all over.
Yeah, I mean, I think there's two pieces of advice I'd give. Stay hungry, right? Really, try to find out as much as you can. Curiosity and hunger, go a long way to a successful career. And then secondly, get involved in your, chapters of, say, ASCE or Earthquake Engineering Research Institute, or whatever flavor, kind of floats your boat. Because those professional organizations are, where you make contacts and you learn a lot of new things, and you really kind of develop as an engineer. I mean, you have your day job, and you have, that piece of it. But if you're not involved in these professional communities, you're really missing a big part of your profession. And so that's what I try to share with a lot of the junior engineers that I work with is get involved in those communities.
Excellent. Thank you so much. We're going to pause here and come back in just a minute and close this out with John in our career factor safety end segment. Stick around. All right, welcome back. It's time for our career factor safety end segment. In geotechnical engineering, just like many disciplines of engineering, it's important to incorporate a factor of safety into your design. But what about incorporating a factor of safety into your career? Today, of course, we're speaking with Dr. John Thornley of WSP. Now, John, you've already had a very successful career, but when you take a pause and look back at your career, what's something that you've implemented in your career to give yourself, let's call it a factor of safety in your career?
I would say that the factor of safety really comes. I think probably others have said it as well, but that saying yes to everything. But you can't say yes to everything without really good support from the people around you. So my wife Terry, she's very patient with me, knowing that I say yes to everything, because I'm very hungry to take on new challenges, and so surrounding yourself with people who support you and that you can lean on as you're taking on new challenges is probably just as important as saying yes. But taking risks to say yes and jumping into things that maybe you're not totally ready for yet, but you can get there. That is a huge reason why. I mean, you say I've had success in my career. I guess it's been a really fun one, but it's I think it's successful. I don't know, so I'm thanks for that. But yeah, it's I think as a result of surrounding myself with supportive people and then taking a lot of risks by saying yes. And I tell junior engineers all the time, say yes to as many opportunities as you can, because you just never know where it's going to take you.
That is true. Well, thank you so much, Dr. Thornley, for coming on and sharing all the great insights with us. You shared some great information and advice. I know it's going to be helpful for those that are listening and those that are watching. Somebody wanted to reach out to you. What's the best way for them to find you on social media, or email you want to share? We could put in the show notes.
I'm on LinkedIn, but feel free to email me john.thornley@wsp.com, and that's an easy way to get a hold of me as well. So
excellent. All right, thank you so much. It's a lot of fun.
All right, yeah, thank you, Jared. Appreciate it.
I hope you enjoyed the episode today. We would love to hear your feedback, comments, and/or questions. Please feel free to go to geotechnicalengineeringpodcast.com, where you'll find a summary of the key points discussed in today's episode, as well as links to any of the resources, websites, or books mentioned during this episode. Until next time, I wish you the very best in all of your geotechnical engineering endeavors. Peace.